Hello students. Hi students. State and proof law of conservation of energy in case of freely falling body. This is our second LAQ for physics first year students. For TS only, IP only. Okay. I am repeating you. This is only for regular students, those who are writing improvement or supply exams. State and proof law of energy, law of conservation of energy in case of freely falling body. Answer. Firstly, you have to write law of conservation of energy subheading, and then you have to write statement, that is, energy neither be created nor be destroyed, but it can transform from one form to another form. Thus, the total mechanical energy will remains constant. Total energy is equals to PE plus KE. This is the total energy formula. TE is equals to PE plus KE. Here, see here, we cannot see energy, or we cannot create the energy, and we cannot destroy the energy, but it can transform from one form to another form. For example, if you want to move a pen from here to here, this is the energy required is only low energy. Okay, if suppose you need to move 100 kgs stone, then you required more energy. That means the transformation of energy has been shifted, has been changed to one form to another form. We can take another example also. By this diagram, freely falling body, here the potential energy will be there, but no kinetic energy is there. After some time it will reaches the ground. Before reaching the ground, it is having some kinetic energy. That means from here to here, when it is releasing, it is having potential energy. When it is coming to the ground, it is having kinetic energy. So by this we can know that the energy can be transformed from one form to another form. Next, here, and then another thing is that total mechanical energy will remains constant. Total mechanical energy will remains constant. So now total energy, the formula of total energy is potential energy plus kinetic energy. So what is the potential energy formula? mgh. For this, mgh will be the formula. For kinetic energy, formula will be half mv square. Formula will be half mv square. So right now, see here, in case of freely falling body, let us consider an object of mass m is released at a height h is equals to capital H. Okay, the initial velocity will be 0 and its acceleration due to gravity will be small g. After some time, it will attain velocity. The potential energy transforms to kinetic energy as shown in figure. By this figure, we can show that potential energy can be transformed to kinetic energy. At position A, VA is equals to 0, A is equals to G, H is equals to capital H. Now potential energy P is equals to mgh, that is equals to, in the position of small h we are writing here capital H. So now Ke is equals to half mVA square, but VA is equals to how much here? 0. So we are considering 0, so kinetic energy becomes 0. Now see here, total energy formula, Pe plus Ke, that is equals to mgh plus 0. Now total energy is equals to mgh, equation number 1. At position B, we are having u is equals to 0, because initial velocity, when it is released, its initial velocity will be 0. At B position, the final velocity will be there, that is Vb. We are considering here the final velocity as Vb. A is equals to G and S is equals to X. By this diagram, S is equals to X here and A is equals to G here, and the height of the position B will be considered as H is equals to capital H minus X. Now potential energy is equals to mgh. What is H value? Capital H minus X. So by multiplying mg with H minus X, we will get mgh minus mgx. Now kinetic energy Ke is equals to half mvb square, that is equals to half m into 2gx. 2 will be get cancelled. How we have got the Vb square is equals to 2gx means, according to kinematic equation, V square minus U square is equals to 2as Vb square. That means V will be considered as Vb square, U will be considered as 0. Vb square minus 0 square is equals to 2gx. That means Vb square is equals to 2gx. Now substituting directly in the position of Vb square, 2gx, like this. By cancelling 2 and 2 here, we will get mgx. Total energy is equals to Pe plus Ke. Pe is mg capital H minus mgx plus kinetic energy considered as mgx. So minus mgx plus mgx get cancelled. Then total energy is equals to mgh. This is equation number 2. At position C, U is equals to 0 and now V is equals to Vc. And A is equals to G, S is equals to H, capital H, small h is equals to 0. Now see here, at this position, the height will be considered as 0. The height will be considered as 0 here. But the displacement will be considered as S is equals to capital H. Okay. And velocity, final velocity will be considered as Vc, and the initial velocity is considered as Va is equals to 0. So right now here, see here, U is equals to 0 we have taken, V is equals to Vc we have taken, A is equals to G we have taken, S is equals to H we have taken, and small h is equals to 0. Potential energy is equals to mgh, that is equals to mg into 0, that is equals to 0. Now kinetic energy formula becomes half mvc square. Now according to same thing, kinematic equations, we get v square minus u square is equals to 2as, vc square minus 0 square is equals to 2gh. And now Vc square becomes 2g capital H. Potential energy formula mgh, h is equals to 0, so we have taken 0 here. And kinetic energy half m Vc square is equals to how much here? 2gh. So we are taking 2gh here. Okay. Now after this, kinetic energy has been made of mgh, because cancellating 2, this got cancelled, 2 and 2, numerator 2 and denominator 2. So we will get mgh. Total energy is equals to potential energy plus kinetic energy, that is 0 plus mgh. Total energy is equals to mgh. This is equation number 3. From 1 to 3, the total mechanical energy remains constant. Hence, it has been proved that in case of freely falling body, the law of conservation of energy has been conserved or proved. So take a screenshot of this. Okay. Is it okay? This is the question here, state and prove question. Okay, take here, from here only. 1 second. Okay, and then this one. Okay, thank you students, bye.